Hello class, today we're going to talk about data structures. This is not to be confused with data types. That is, data types are a different type of data. It's a categorization of types of data that you have. Data structures is bigger than that. Data structures is what do we do when we have a large amount or a large pieces of data. So when you hear data structures, I want you to think about lists. In fact, we're going to talk about lists here in a little bit, but data structures are ways of structuring different sets of data that you have. There are various ways to structure data, and a lot of computer programming is figuring out how to structure data in a coherent and a feasible way. And so we are going to talk through the different data structures, and hopefully you'll get a little bit of an idea of what they are as we go through. Your first and very basic data structure is what is called an array. An array is when you have a set amount of things, and that amount of things is not going to change at all. It is when you have a collection of something, and it doesn't really matter what order they're in. All that matters is that you keep track of where they are at. And so how an array works is that each set of data is given its own number. So let's talk about numbering. In the real world, we start numbering something with 1. If I were to count you as you walked into the classroom, I would say you're the first student here today, you're the second student here today, you're the third student here today. However, remember in a computer, every set of data is a switch that can only be a 0 or a 1. And so in computers, when you start counting, you have to start at 0. So the first spot in any given array or any given list is a 0. And so that is the first thing you need to know. The next thing you need to know about an array is that the items are not connected together in any way. And so when you think about an array, think about a seating chart. If at the beginning of the quarter I had made a seating chart for all of you, and you each had a chair to sit in, somebody would sit in the 0 chair, somebody would sit in the 1 chair, somebody would sit in the 2 chair, and so on and so forth, then that is your seat for the quarter. Now let's say you were to get up and go to the bathroom. Does that mean everybody would shift into your chair? No. Your chair would just be empty. In computer language, we would call that null. We would say that is a null chair until, of course, you got back, and then you would fill that chair again. And so in an array, the items don't shift or change around at all. Usually an array works best when you start with a set amount of data and you know that set amount of data isn't going to change over time. And each set of data is given a space, but it doesn't really matter what order it's in. It doesn't really matter how they're linked to each other. That's an array, and it's the most simple form of a data structure. The next data structure, building from the array, is what is called a linked list. This, unlike an array, is when the items are actually linked to each other, when it is actually important that the items remain ordered in a particular way. So going back to my example of a seating chart, a seating chart would be an array. The class roll would be a linked list in that if I were to delete number 2 from my list, if they were to drop the class or change to another school, they would be deleted out and everybody would shift up 1. So 3 would become 2, what's in number 4 would become 3, and so on and so forth down the line. That's a linked list. Now, when you make a linked list in a computer program, you actually have to write an algorithm that shows where the next item is. In an array, it doesn't matter where the next item is, because if this item is gone, nothing happens. In a linked list, we actually have to indicate where the next item is. That is called a, wait for it, a pointer. A pointer points to where the next one is. And so when you have a linked list, you have the data itself, and then you have an arrow or a pointer that says, look at number 2 for the next one. And then 2 has the data, and then it has a thing that says, look at number 3 for the next one, and so on and so forth. Pointers are very, very important when you're dealing with data structures and arrays. Then when it comes to linked lists, you really have 2 basic types of linked lists. Your next linked list is a queue. That is your first type of a linked list. A queue means that the first item to come into the queue is going to be the first item that we take out of the queue. So here, think about a line. It's your typical line. So if I go to the grocery store, the first person to stand in the line is going to be the first person to go out of the line to be helped at the cashier, and then so on and so forth. This is called FIFO, and it stands for first in, first out. So in the computer world, if we were to remove item 0, then item 1 would shift into item 0 spot. Item 2 would shift to 1, 3 would shift to 2, and 4 to 3, and so on and so forth. That is a queue. The second basic type of a linked list is called a stack. In many ways, a stack is the opposite of a queue because in a stack, the last item in is the first item out. So when you think of a stack, think of trays at a diner or a cafeteria. Usually, the last plate to be put on the stack is the first plate that is going to be pulled off of that stack. So in a computer terminology, when the computer program goes to grab an item out of the data set, it will grab the latest item first. In this case, it is the 4 item. Then when it comes back, it will grab the 3 item, and then the 2 item, and then the 1 item, and lastly the 0 item. So the last items in are the first item out. That is how a stack works. Lastly, we have trees. Trees are not lists. They are called a dynamic data structure, whereas lists and arrays are called a linear data structure. But trees are for when you have an hierarchy that you want to map out. And so a tree has parent nodes and child nodes. The data sets then are called nodes. So think of a tree as in your family. You have a family tree. That's the classic example of that. So you have a grandparent node, you have a parent node, and you have a child node. And how a tree works is that you have a 0 level, not a 0 item, but a 0 level. And at that level, that's your top parent node. And then on level 1, you have the first child nodes. On level 2, you have the next child nodes, and so on and so forth. And so the way we navigate a tree is we look at the 0 node, and then we look for what node is in there. That's called a tree. Your basic type of tree then is called your binary tree. A binary tree is simply a tree, but it's only where each parent can only have 2 nodes. And so a binary tree is only going to grow by 2 each time, and that is used to trace logic decisions. Usually in a binary tree, the right node is somehow lesser in value than the left node. Somehow the right node means that the person making the decision has taken a step down, whereas the left node means they've taken a step up. And so that's usually a binary tree is for mapping out decisions, yes-no decision. And so those are your basic data structures. They have a huge effect in how you write computer programs, and they're very important to know. Especially they're very important when you're dealing with putting a real-world situation into a computer program. Then these are helpful to ask yourself, okay, am I dealing with an array or a list or a queue or a stack or a tree? If you have any questions, you can leave them in the comments below.